Today we're going to talk about how to work with the BigTreeTech Manta M8P version 2. Now, as you can see, I have the older version of the Manta up above, and I'm going to point out a couple of differences, then I'll go around the board and explain the functionality. So the first difference, obviously, right here is the MCU. That's the processor for the actual board. As you can see, it's kind of tiny in comparison to the MCU over here, which I'll explain in just a moment. But as you can tell, they're significantly different. The other difference that you'll see is that the EXP1 and EXP2 are non-existent on the version 2, but we do have an EXP port down here, which uses a ribbon or ZIF type cable. So those are the main differences. Obviously, there's some cap differences that you can see on the boards from here and here. So the other thing that is different is the actual motor power, which I'll also show in just a second. But those are the main differences. There is a RGB port that was removed from the newer version down here so that you only have one instead of two. Those are the main differences. There are other slight differences that I'll go into in future tutorials. But as you can see, when the board first arrived, there's no jumpers on the board. The only one that I did add was the actual 5-volt power one right here. Normally, that would be non-existent until you actually install it. So what I'm going to do now is I'm actually going to talk about this board and the functionality on it real quick. So as you can see, I'm going to first show you what the board looks like by itself, but before I do that, I want to actually show you the actual differences or main differences that I did find on the actual board. So with the M8P version 1.0, you can see what the actual MCU or processor is. It's a Core M0 STM32G0BV VET6, and it's 64 megahertz. Now, if we look over at the version 2, you can see that it's an actual M7 STM32H723 ZET6, and it's 550 megahertz. The other thing is the actual input voltage for the steppers. So as you can see right here, it went from 24 volts. Now they say it goes from 24 volts to 60 volts. The other thing is the heat bed. It looks like the amperage has dropped a little bit in the version 2. And of course, I've already talked about the EXP1 and 2 being different and not present on the version 2. Obviously, the pinouts have changed, and the reason I left this on here was that the actual pinouts for the actual processors are different. So that's why there's a difference between the two. And then the other thing is the RGB port being 2 instead of 1 with the newer board. So let's go back over to the board and I'll start to explain these real quick. Obviously, we have our power right here. And as you can see, if I pop this up, you'll see that there's actually screws that we can actually bolt down our power supplies. Usually I use a ferrule connector unless I have the other type, which is kind of like a fork. So right here we have our motor power, our board power, and you can see that the polarity of negative and positive, being voltage and ground, are listed on top. We also have the bed power, and then we have the output bed power right here. Over here we have our actual thermistor power, so there's 4 different thermistors that you can work with. We have our end stops that are located up here, so there's 6 of them that you could possibly work with. Over here we have our actual steppers, and as you can see, you can use anything from an A4988 all the way up to a TMC 5160 Pro. And of course the jumpers need to be actually added in order to work with it. There's also a cooling fan port up in here to cool the actual steppers continuously. You could also do it through the actual fan ports down here that we have that are selectable for actual voltage. So I believe this one might be 24 volts because it's powered directly from the board, if you're using 12 or 24 volts to power the board. Preferably now I use 24 volts. As you can see down here, the selectable power for the actual fans that we could use being these 4 up here and then 2 down here would be either 5, 12, or 24 volts for power, with the jumpers being added. Obviously these are more advanced fan ports down here, so they're going to be slightly different. Then over in here we have our actual module for our computer that we can attach to the board. Now I don't have them all lined up like I normally would, but I'm going to be using the CB1 for the board, and it's version 2.2 on here. So there's actually ports underneath here that'll connect to it. I'll show you that in just a second. And then we'll have to load an operating system on this board. So also there's cooling that can be attached to this to actually wick away the heat. Over here we have our USB ports. We have 1 and 2. Then we also have our Ethernet port, and we have the ability on the CB1 to actually do Wi-Fi. So that's what we're going to actually do in this case. Obviously there are jumpers that you can use for this. These are actually adjustable, meaning that you don't need jumpers. You switch the position to actually do your settings. So 3 and 4 would be used for that if you're using something with eMMC that's on the board. Now this one does not have it, other boards do, as well as the Raspberry Pi CM4 versions. Now keep in mind, with the CM4 Raspberry Pi type, there are 2 different types, or actually there's I think 32 different types, but usually Wi-Fi and then the regular CM4 board will use the SD card. Whereas if you have the eMMC type, then you can actually load directly to the board without an SD card. So I've covered pretty much all of that. We're not going to have to change these switches for this board. I'm just showing you the simplest install. So let me show you some of the other functionality. Obviously we have our pinouts for a Raspberry Pi here. Up in here we actually have the fan that provides direct power to actually cool this. Now you're going to have to check the voltage of that fan just in case. You can either, I believe, use 12 or 24 volts depending upon your input voltage to the board. So now that we understand that, we also have a jumper that we can place here, which I already have on here, that will power the board when we're using 5 volts of power from a C-type USB. So we also have our HDMI ports right here. So we have 1 and 2. This will allow us to do display in multiple ways, as well as here. And then underneath the board we have a couple of other things that we can attach. So let me show you the remainder of what's on this board. Obviously there's some functionality in here I want to talk about. There's the thermistors, which I believe are right here. So this provides thermistor or temperature sensors for your heat bed, which I believe is this one, and then each one of your thermistors thereon after. So inside here there's a port, I believe, for the TFT display. That would normally be used with Marlin's firmware, but in this case Marlin, as of this moment of recording, does not have an actual configuration yet for this board. So you're stuck with Klipper until they fix that. That's probably a little bit of time away, and I'll show you how to check that in a second as to why that doesn't exist. We also have an RGB port in here someplace. We have a actual sensor for like a BL Touch or 3D Touch. And there's a couple other things for, I believe, I2C and SPI, but I'll show you that on the actual monitor. So if we go over to the monitor for a second, I'm going to bring up the actual board pinouts so you can see. So here's our RGB display. Here were the thermistors that I was actually talking about down here. So you can see THB is thermal heat bed. Then you have TH0, which is your thermistor for your first extruder, which is HE0. And then it goes over to HE3. So you're going to have to examine the board, and you can see the silk screen of where these are located on the board. Obviously, we have a servo control right here. I don't know why they call it a steering engine, but it's 3 pins. And I'll show you a little bit more detail on that later on, but you can see the fans, and you can see that the EXP port for EXP 1 and 2 goes through this connection right here now. Obviously, there's your GPIO pins for your Pi, which I've already spoken about. And obviously, there's a couple other things where they say ADC in. This is probably for your filament detect. I don't know why they're using ADC in, but it's obviously outlined on this board. We have our I2C pins right here. And of course, this is UART for TFT display, which I showed you just a moment ago. So you can see the actual processor really clear here, where it says 32H723. It's actually STM. So it's an actual ARM processor, which is a reduced instruction set processor, I believe. But I have definitions that are up on my Patreon if you want to check those out. And you can see the actual power that's outlined here, but it's not very good because it says power in. Obviously, you're going to have to either consult the manual or the actual pinout diagram, which I'll bring up right now. So over here, we have the pinout diagram. Let me expand this so you can see it. And you can see all the pins that are located around the board and what they actually attribute to. So you can see there's a GPIO pin right here, which is for the actual pinouts that come off your Raspberry Pi. At the moment, I'm not going to show you how to hook up the fan for it, just because I have other things that I want to show you in this video, and I don't want to make it too long. So as you can see, there's also a CAN bus up here that I didn't cover, and a couple other things for the fans that are located down in here. And then, of course, there's a setting in here, I believe. I don't know if they marked it quite right. So I'm going to probably skip over this for now until we actually have more detail to explain it. But obviously you can see that the fan pins for the more interesting types of fans are down here for these. So now that I've talked about this way too much, I'm going to show you a couple other things. Obviously there's the servo, which they now call motor. And of course you have PS on and your RGB, your SPI, and everything else that I pretty much covered. So let's take a quick look at the board on the desktop. I want to show you underneath. So underneath this board, there's a couple of things that they don't show you. Now obviously I have it inverted, but you can see that this is the MCU card. This is for programming the processor on the other side of this board. And then you have your control SD card connection for your actual either Pi type or CB1 type connector. Then you have obviously two other connections underneath here, one for display and another one for the camera. So that gives us several different types. And then I believe there's a SPI type one. I can't read it upside down. So it does say SPI. Let me rotate it over. SPI screen. So that would be for the special screen that just came out for the display from BigTreeTech, I believe. So now that we've got all that figured out, we're going to actually learn how to connect this up real quick. So the firmware, when it comes, is already defaulted to be loaded for the MCU. But in order to connect this, there's little connectors underneath here. So you have 1 and 2. You're going to have to line up the holes when you place this over it so that you place it the correct way, because if you do it backwards, it will not work. If you do need to remove it, you're going to pop it from right here with a little bit of pressure with something like this. So to put this on, we'll match up the actual holes. Then we'll apply pressure on the left and the right to put it in position. Now we're going to have to flash the drive in a moment. So what I'm going to do is I'm actually going to grab this and place this in my card reader for my computer. This will allow us to load the operating system for this board. Then we can actually power it through here because we have the jumper that's actually added right here, which I'll pop out so you can see. So if I lift this out, you can see the jumper. We're going to place it right back on those 2 pins, and this will allow us to power the board so we can work with it. If you're working with TMC type steppers, you'll remove this jumper when you're using direct power because it'll reset your actual TMCs. So keep that in mind in the future. So let me disconnect this for a second and attach the actual antenna. I'm not actually going to attach this at the moment to keep it cool, but in the future you'd want to do that. As you can see, there's a little cup under here. So we're going to place this on here. We're going to click it down until it's on there. And then what we'll do is we'll actually load the actual firmware on here, or not the firmware, the operating system, through the USB card. So let me plug this in and get this set up for you. Okay, so first I want to show you some quick things. Obviously I have the drive in here. I had the original version up loaded on here. I had to remove it so that you could see this. So currently it thinks that it's not formatted, so I have to remove it and reinsert it for a second to fix that, because I just removed the previous partitioning of it. So hopefully this will be better. So apparently it has an issue, so I'm going to format it real quick here. And so I'm just going to do a quick format. It's going to be FAT32 or file allocation table or file access table. I always forget which it is. So hopefully this will take care of the problem. I may have to pull the drive and put it back in, but it looks like that solved the issue. So now that that's taken care of, I'm going to show you Marlin real quick. Obviously, we would normally want to use Marlin sometimes for the firmware and maybe Octoprint. Currently, that facility is not available until they update the MCU to be built. And I'll show you what I mean by that. If I go over to, let's see, the GitHub page. On the GitHub page, I'm going to go over to code. And then inside here, I'm in bugfix 2.1.x. So this is under current development. That means that it doesn't currently exist as a released actual firmware you can load on the board. It is something you can experiment with, but note that if you have issues, it's probably because it's under development. If you wanted the actual build, there's actually a tagged build in here that you can actually go to. Hopefully it'll show up in a second. Here we go. It's 2.1.2.1. But we're going to look in the bug fix because this is where it's going to reside if it's new. So we're going to go to Marlin. Then we're going to go to source. Then we'll go to core, and then we'll go to boards.h. If you do a Control F and search on Manta, you'll see what I'm talking about. There currently is not a Manta 2 because there's only 10 instances of Manta, and that means that it's not there yet because version 2 doesn't exist. The other thing that we're going to have to keep in mind is that on the Klipper web page, we currently don't have an actual configuration for this either. So they've actually been good enough to create one, but I'll show you real quick under configs. if you go to the example configs that you would normally use, Manta is version 1.1 or 1.0. There's not a 2.0. So it will not be here. But if we go to the BigTreeTech website and we click on repositories, then type Manta, you can see the M8P right here. This is where you'll find the information on your board for version 2. And inside here, if you click on firmware, you'll see that you have your bootloader and then you have your config. So this is already loaded. This actually should be called firmware.bin, but they call it bootloader for some reason. That would be your normal firmware load. So you'll have to rename that if you want to reload it. So inside here though, this is your configuration for all your pinouts. So the pinouts, if you can see right here, we have like the dir pin on your y-axis. Let's look at the one for the x-axis. It's PE5. So sometimes they do these incorrectly, but let's take a quick look here. So your dir pin is PE5. So if you are having issues, you can always check these pins to see they match up in your config file for each one of the functionality that you see. So there's also some hints on how to build it. Up here, if you want to build it for your board type, you can actually do it through the actual configuration for it that is actually giving you the hints on what you need to configure right here. So they've already taken care of that. I've already downloaded it to my computer. I haven't reloaded this yet on this board because it was loaded by default. So let's get ready to actually set up the install. In order to do that though, we have to go back to the BigTreeTech main page, go to repositories again, and we're going to type CB1. So you have a kernel and then you have the OS image. If you click here, you can see that there's an image that you can actually pull down here. So you can say latest system image and click on this. And this will bring you to the actual image that you can click on to download. Currently, I already have it downloaded, so I don't need to do anything special. The other thing I did want to show you real quick is obviously here's the current password and login. You'll probably want to change this with the Linux command, which I hopefully will put in the description. Otherwise, remind me. But that will show you how to change it. It's pretty easy to follow when you do it in actual the TeraTerm session, which is actually the remote connection. But for now, we're going to simplify this as much as possible. Since I've already downloaded this, I need to open up Raspbian Imager real quick. So in Raspbian Imager, I'm going to choose my storage device, which is my SD card. I'm going to choose my OS. It's going to be a custom OS that I've already downloaded. So I'll click on that. It'll bring up my downloads folder and then the Klipper kernel 5.16, which I'll show you how to find in just a second. But I'm going to click write and I'm going to say yes. This might take a few moments to actually accomplish. So it's going to write for a few moments, then verify. I may pause the video depending upon how much time it takes. But let's look over here real quick at the actual downloads folder, or not downloads folder, excuse me, the CB1. So if we click on this to get our image, you can see that it's located right here. So the image that we want is probably going to be under this. And then you can see that the actual Klipper image is the one that I'm pulling right here. This will take, at least on my computer, a little bit of time because it's 1.24 gigabytes to pull down. But that's the environment that's currently loading on the Raspberry Pi. The other thing we're going to have to keep in mind is that on Klipper, if we go back here, there's going to be install configuration. Under installation, there's going to be some issues that we're going to have to check for. And I'm skimming down to right here. This is to help us find our MCU. The other thing that we're going to have to worry about is the actual Marlin folder. We're going to have to copy this file. So I'll show you this in a couple of moments. Obviously it's going to take a second for this to load because we're only at 61%. But essentially there's going to be some installation that has to occur. So I'm going to pause this for a second and I'll bring it back up when it's almost complete. Okay, as you can see, it's completing with the verification after writing. So it's going to pop a message in just a second. I'll show you what you have to do. So here's the message that it's completed. We're going to have to remove the SD card. So I'll show you that real quick. So I'm going to have to pop out the drive for a second, place it back in the computer, go back over to the desktop. We're going to get an error message that looks like this. Do not format, just click cancel, because the drive is now partitioned so it doesn't recognize it. So we'll bring up an actual Explorer window. We'll go over to the drives and you can see there's a boot drive and an E drive. We'll go to the boot drive and inside here we have to find the actual system config. So I'm going to right click. I'm going to edit this with NotePad++. So when it comes up, we're going to have to set it up for our Wi-Fi device. In this case, we have to put our actual Wi-Fi router name and our Wi-Fi password. So I'm going to do that real quick and save it, and then I'll show you what you do next. I'm just going to do this off screen. Okay, now that I have that saved out, I'm actually going to pop out the drive in a second, and I'm going to have to bring it over to the desktop. So let's do that right now. So I'll pop out the drive. I'm going to put the SD card inside of here. So you can see that it's probably going to go like that. Then we'll place this back down. The antenna is obviously still here so we can hear the Wi-Fi. I'm going to connect it here, but before I do anything else, I'm actually going to see if I can show you the video of what's occurring. So I'm going to connect up here with one of our connections for HDMI and see if I can bring the screen up. Hopefully. I've been having trouble with it today, that's why it's taking so long, but let's power it up and see what happens. Okay, let's go over to the computer. Sorry that this is all over the place, but let's bring it up and see what we can see. So apparently it's on the fritz, so we're not going to worry about that portion for the moment. I'll minimize this for a second. Essentially now we need to find out where this exists. So I'm going to bring up my network configuration for my router. Obviously I'm going to have to put the password in and blur out part of the screen. So let me show you that in just a second. So here is the actual devices on my network. The BTT CB1 is what we're looking for. So we're going to copy this and we're going to place that right here and see if we can see it on the network. So this is the connected device that we saw on our connected devices on our router. So it might take a second to actually load. I may pause this for a second to give it a chance and then we'll see what happens. So let's see what's going on here. Do a reload. So let me pause this and double check. Okay, I found the issue. Apparently I didn't push down hard enough to connect it over here. So hopefully the display will work now. So I'm going to plug this back in and see if we can bring up the display of it booting. Sorry for this delay. This is kind of things that happen when you're working with it. So let's see if we can actually see what's happening. There we go. So it does say that it's booting. Hopefully the IP address that we checked is still valid. It may or may not be depending upon what I've done. So I believe it's 192.168.1.7 per connected devices on my actual router. So as soon as this completes, this is what it would look like on an actual connected display. But I'm using the HDMI port to pipe it in so you can see without the reflection of the display during this actual tutorial. So in a second, you'll actually see the actual main boot screen. It may have an error on it, which we're going to anticipate. But as you can see, it says Klipper's disconnected. So we're going to go back over to the computer in a second, and we're going to see if we can see what's going on with the web browser. So let's go over to the actual desktop of the computer. You can see that we're not able to see it at the moment. There's a couple of things occurring. First of all, we're not up to date with everything over here. You can do that by clicking here, and then there'll be an update all that will appear. I'm going to skip that because you can do that on your own. Just remember, if the OS isn't up to date, you may have issues with these, so you may have to update this one first. But let's look at the files that we have over here. Printer.config is pointing to a generic print file, which we currently do not have. So we're going to close out of there. We're going to have to go over to the Marlin page for a second. We're going to have to copy the actual name. So I'm going to go back a menu here. And let's see, I'm got to be on the right thing. So obviously I'm not. So we'll back out of here and we'll find it this way. So we'll go to BigTreeTech. This is on the BigTreeTech GitHub. We'll then go to repositories. We'll type Manta. It's the M8P. Inside the M8P, we'll go to our version. We'll go to firmware. We'll copy this file name right here. We'll go back over to what we had here, and we'll go in this file. We'll rename this right here with a Control V. We'll paste it. Then we'll save and restart. It's not going to be right yet, so we have to click Create a File. We'll give it the file name that we're working with. We'll create that. You can see it right here. It has nothing in it, so we're going to have to go back over to here. Click on this file. Copy the contents with this. Go back over here, hit Control V or right click and paste. And now we've got everything that allegedly is there for pinouts. You may need to check these pinouts to make sure they're correct, but for now we're not going to worry about it. We're going to find the MCU like I normally do to show you this. So I'm going to copy this piece. Excuse me. So we'll remove that space. We'll go up to the top and we'll paste it up here. Now that we have that, we're going to have to actually set up the correct pathing, and I'll show you this now. So what we're going to need to do is open up TeraTerm. So let me bring this over so you can see it. We'll do File, New Connection. This is the IP address. We'll click OK, Continue. Then we'll put in the BIQU. The BIQU for the passphrase or password, and click OK. So now that we're in here, we can actually do the other operation. So we'll go to Klipper. We'll copy the command for the listing of the directory devices. We'll paste it over here and hit enter. And here is our new path. So let's minimize here. Go back over to the browser. I'm going to show you a difference between the two by typing serial, comma, or excuse me, colon, space, and then paste it. That is our device. This one up here is not relevant, so we'll try and comment it out using the control / that's underneath the question mark. And then what we'll do is we'll save and restart. Now that that's complete, we're going to have another issue. What this says is the ADC is out of range. I'll show you how to fix that now. So we're gonna have to go over to the desktop. I'm gonna pop these in with the power on. These are actual thermistors. So first the bed, which is right here. Then we'll do the actual hot end one. And these thermistors are glass beads that are used to tell temperature. So I've covered it before, so for now I'm going to skip talking about it too much. So let's go back over to the desktop. Now, as you can see, for the actual browser, what we're going to need to do is try a reset. Then we'll go to the dashboard. And we'll try a firmware reset. And as you can see now, we have our actual thermistors working. So let me see if I can demonstrate this real quick. So as you can see, I have the actual board and thermistors right here. So I'm going to grab one of them and I'm going to put my thumb over it to heat it. So we'll see if there's a temperature change right here. Now, as you can see, the extruder temperature is going up, which is in red. So we know it's actually working. So at this moment, I'd like to thank my patrons, people on PayPal, Buy Me a Cup of Coffee, and any other social that I have out there for their donations that makes these tutorials possible. So everyone, take care, be safe, and I'll talk to you later.